All right, folks, we're going to dive into our last section here, 7.4, properties of similar polygons. And our essential question today is, how can I find missing measurements between two similar figures? All right, so the first thing I want to say is, if two polygons, or any number of sides shaped figure is a polygon. If two polygons are similar, these two things are going to happen. The first thing that's going to happen is the corresponding angles, or angles in similar positions, like we learned about corresponding early on this year, those are congruent. The second thing is, since the corresponding angles are congruent, or the angles in similar positions are the same, that means the corresponding sides are proportional. And that means it's just really that they can be dilated to the same thing. All right. So, for example, I guess put 1 and 2 there. So let's make this example A. Just make example A. We have a small triangle and this larger triangle. All right. We'll call this one triangle A, B, C, and we'll call this one D, E, F. All right. So I don't need to know any sides yet. So let's talk about our corresponding angles are congruent. So we'll go back to our angle arcs. And what that means is, with these angle arcs, angle A and D are congruent. B and E are congruent because they get the 2. C and F are congruent because they have the 3. Even though these triangles are not the exact same size, they can have the same angle measures. That's okay. All right, so now let's go through and let's say, all right, this length is 12, that length is 7, this one is 36, this one is X. All right, so we gotta figure out what X is. All right, so the very first thing you might think of is like, all right, if I'm gonna dilate this one to larger one, how can I go from 12 to 36 and then 7 to X? Well, hopefully you could look at this and just say, all right, well, obviously 12 times 3 is 36. That means if I take a scale factor of 3 on the small one, that's going to give me the large one. Therefore, this one has to be 21 because 7 times 3 is 21. So this length is 21 units. And sometimes the numbers are that simple to work with. However, sometimes they are not. Let's go to example B. Example B, I'm going to give you this quadrilateral. And that quadrilateral. All right. So let's say this is 6, this is 4, this is X, this is 10.5. All right. So now this might be a little bit harder because I'm going to compare, this is our long side, these are our short sides. This angle and this angle are both right. This angle and this angle are right. So the angles are going to match up. I just got to figure out how I can go from 6 to X and 4 to 10.5. It's not that simple. So this is where we create two proportions, which I kind of alluded to in our last lesson. All right. So let's go with our short sides, 4 to 10.5. I got to figure out how I go from 4 to 10.5. Then I'm going to figure out how I go from 6 to X, and I want them to be the same. This is a proportion. This is something that you solved in 7th grade. Or 7th grade math, I guess I should say. So we'll use cross multiplication. 4 times X is 4X. 10.5 times 6 is 63. And I set them equal to each other. I solve the equation by dividing by 4. And X is going to give me 15.75 units. So that's what X is. 6, and x are in similar spots, 4 and 10.5. That's how I want to set those proportions up. I don't want to get my numbers mixed up. Then I won't get an accurate number here, and it won't make any sense. Okay. Example C. Our last example of doing something similar to this. All right. Before we get to that point, though, our movie quote for today is, if I could only have one food to eat for the rest of my life, that's easy. Pez. Cherry flavor Pez. No question about it. From a classic movie, one of my favorites. All right, so example C. Here's you. Yay. Look at you, you look so excited. And then there's the light pole outside your house. Okay? We know that you are 5 feet tall. We don't know how tall that light pole is, so we want to figure out how tall it is. So what we can do is we can see how long our shadows are. Your shadow is 3 feet. You measured the pole's shadow. It's 11 feet. You want to know if this pole falls from in your yard, if it's going to hit your bike or your house or your pet iguana. All right. These are two similar figures. This is a triangle that's been created. You may not say, well, what are you talking about? There's no triangle. Well, your shadow is created by the sun. The sun's coming at this angle. At this angle, making that part of the triangle. You are the height. Your shadow is the length. The hypotenuse is the sunlight coming in. Same thing here. This is the height. This is the length. Hypotenuse is the sunlight coming in. So I can create a proportion to figure out how tall this light pole is. So, okay, 5 to the height here. Just don't know what that is. So instead of 5 over question mark, I'll just put it as 5 over x, because that makes more sense. Then I gotta go from 3 to 11. And I'll set them equal to each other. We'll cross multiply. And when we cross multiply, we have 3x equals 55. We divide by 3 on both sides. And we get x equals 18 1/3 feet. That's how tall that pole is. So make sure you're staying away if it starts to fall. If it hits you, that might hurt. All right, that's all I have here today for properties of similar figures. We're going to be on page 549 in our textbook. So make sure you look for that work. Yeah, that's really all I got. If you have questions, you know where to find me. Peace.